Okay, hello and welcome everyone. So in this video, we were thinking about cost innovation, which is going to be important because as we're thinking, we realize that we want our firm to end up being in a market where they have some degree of market power, where they can charge a price above marginal cost. There's two ways you can do this. You can introduce a new product or new product variation such that consumers have a higher willingness to pay for the product than either existing rivals or it's a completely new product to begin with. Another thing you could do is you could be operating in an existing market and then just do it better, right? And so here we're going to think about that aspect. We're going to think about how actually a market could go from being plausibly competitive, even perfectly competitive, to then ultimately being monopolized. And there's an interesting, important lesson in this example in that you might think, oh, monopolies are bad. Monopolies are bad for consumers. Well, not in this case. So in this case, we're going to have a situation where the monopoly market structure is actually what provides the incentive for the innovation in the first place and leads to a situation where consumers and the firm are better off as a result of the innovation that's happened. All right, so by innovation, we're meaning something that is going to end up generating either some type of variations to the product itself or some type of variations to the way in which the product's produced, right? The idea is innovation is going to presumably increase the firm's competitive advantages through these means, either by product differentiation or by cost differentiation, essentially making the cost lower. As a result, innovation can destroy the competition. It could unseat a dominant incumbent firm, which could be in the same product category or can be in a different one. During the pandemic, Zoom and video conferencing technologies are providing a major threat that has been growing over the past decade for the airline industry, among others, right? And innovation can definitely create entirely new markets. There's a lot of examples you can think about. And so before we kind of talk about these sorts of things, I want to go into this important distinction of innovation. We can think of innovation as a result of, or classified as process innovation or as product innovation. And so I've talked about innovation as creating product differentiation. Well, that's product innovation. That's the search for technologies and producing new products. I mean, that's awesome. That's kind of like at the heart of entrepreneurship, although that's not what we're going to study in these slides here. Here we're going to study the cost-reducing technologies. So innovation, I should go over the definition. This is the search for, discovery, development, improvement, adoption, commercialization of new processes, products, and new organizational structures and procedures. And this is broad. There's a lot of things we mean by innovation. For our purposes, we care about process innovation and product innovation. We will think about product innovation in several lectures in the future when we think about product positioning, we think about advertising and these sorts of things. Today we're thinking about process innovation. So this is the investment in searching for cost-reducing technologies. Process innovation relates to cost reductions, and we make a further distinction between large and small innovation. How will you determine if there is a large or small innovation? Well, our definition is going to amount to, after the innovation, is the firm able to set the monopoly's single price monopolist price, or will it be undercut if it does that, right? This cost advantage, we're going to assume it's going to give our firm a monopoly power. However, it may not be able to fully operationalize that monopoly power. If it is, we'll call that a large innovation. If it's not, we'll call that a small innovation. Large innovations benefit consumers and the firms. Small innovations, at least as we're defining in this class, will benefit primarily just the firm and then should have little effect on consumers. So we're going to think of an industry producing an identical product and assume firms are competing in price. We're assuming we've got Bertrand competition. Bertrand competition means you've got a collection of firms, they're setting their prices, and they're strategically interdependent in the sense of, I know my price is going to affect your price. So the standard example would be, suppose we both have costs of $2. Suppose the current market price is $3. What price should we set? Well, maybe we're initially setting prices at $3, but I get the bright idea that I'm going to set a price of $2.99. I'm going to capture the market because I'm now cheaper, and I'm not giving up much above what I was previously pricing at. Splitting the market with you, in fact, maybe at $3, $2.99 is going to give me 99-cent margin on each unit I sell if my cost was $2. But you're going to see that and you're going to be like, well, wait a second, I'm going to set $2.98, and so on and so forth. We'll keep undercutting until prices crash down to marginal cost. And it turns out Bertrand competition with identical cost is going to lead to the price equals marginal cost outcome. I've got a video on Bertrand competition. You can go ahead and type that into my search. Be sure to spell Bertrand correctly. It has an R here, Bertrand. Anyway, so Bertrand competition, if we have identical cost, leads to the firm producing where their marginal cost is equal to the price. If we have non-identical cost, how does this go? Suppose my cost was $2, your cost was $1, the current price is $3. What's the price going to be? Well, you can keep undercutting me actually down to $1.99. You'd set a price of $1.99. Why? My costs were at $2. I can't go below $2 without making a loss. Your costs are at $1. So you get a 99-cent premium. If you set a price of $1.99, you've captured the market as a monopolist. And as long as you don't set a price at $2 or higher, I have no say in the matter because I can't be in the market. And so if you have different costs with Bertrand, then we'd expect that the price is going to be the lowest it needs, the highest possible price that undercuts everybody else. And that actually is going to be harmonizing with how we'll define a small innovation in this class. We'll talk about that shortly. All right, so here's the setup. Let's assume initially all firms have the same technology, therefore the same marginal cost, some positive marginal cost. Initially, there's a unique Bertrand equilibrium where all firms are going to set a price equal to marginal cost. They're going to produce some amount of units and everybody makes zero profit because their price is equal to marginal cost. Right? So the initial starting point, if we all have costs, identical costs, the price is just going to be marginal cost. That's our Bertrand equilibrium. Now suppose one firm invests in innovation and ends up with a lower unit cost technology. So their costs have now fallen below whatever was that original shared unit cost. So now that monopolist profit maximizing outcome happens. Their output corresponds to where their marginal cost equals marginal revenue. Find where marginal revenue crosses marginal cost, produce that output, charge the single price that associates through the demand curve with that quantity. So now we need to distinguish whether that's possible. We'll call that a large or a small cost reducing innovation. PM is going to be the monopolist price associated with a monopoly with unit cost of C. The innovation is large if the monopolist price is below the initial shared marginal cost, such that they are undercutting the current market with the monopoly price. The innovation is small if the monopoly price is above the original prevailing shared marginal cost, right? So they are not able, you've got lower costs, so you can undercut your rivals, but not with a monopoly price. By monopoly price, I mean the single price monopolist price. Yeah, your price that you're going to set, it's going to be epsilon below everybody's existing cost. It's going to be a monopoly price in the sense that you're a monopoly. But when we say monopoly price, we mean the price corresponding to where marginal cost equals marginal revenue found via the demand curve. So I'll describe that in a bit. Like I say, I'm going to show this graphically in 2 slides. For the sake of the video, let me just show you that picture. You could maybe take a screenshot or something, and then I'll come through and I'll talk through it. I'm going to come back over the picture deliberately in a bit. So the cost reduction from C0 to C1 is a small innovation. Why? Because the monopoly price is going to be higher than C0. So what the innovating firm is going to be relegated to doing is setting a price that's essentially the original price. They're going to undercut by some small epsilon. Epsilon we mean as small and positive. This would be like a small number that's close to zero. So, if we're talking in terms of dollars, maybe this is 1 penny or something like that. So just a small amount below existing prevailing price. The small innovation, therefore, doesn't change the market from the perspective of consumers. They're effectively paying the same price for all practical purposes. The big difference now is that you've got one firm that's captured the market. So as a reward for innovation, the firm does make a strictly positive profit because there's a difference between their existing cost, which becomes the price, and their new cost, which becomes their marginal cost. And then this is actually price minus cost times quantity is profits, right? So there will be profits, just not as large as a true monopoly. A cost reduction from C0 to C2 will be a large innovation. This innovating firm undercuts rivals charging the pure monopoly price, the single price monopolist, right? This monopoly's price corresponding to that quantity where marginal cost equals marginal revenue. What's happened? The monopoly price is below everybody else's price. So the large innovation reduces the market price, allows the quantity to increase to a quantity of 2. That's why consumers and firm wins, right? Lower price, larger quantity, everybody wins. As a reward for innovation, monopoly makes standard monopoly profits, right? That's this picture. So this looks terrible. The price is on the vertical axis. The quantity is on the horizontal axis. Initially, everybody has cost C0. The small innovation lowers one firm's cost to C1. The large innovation lowers one firm's cost to C2. So when everybody has the same marginal cost, they're going to set marginal cost equal to, or price equal to marginal cost. They're oligopolists, so they can set price. And they're going to produce this output. What's going to end up happening? Well, the oligopolies price is going to be P0. Their cost was C0. So actually this triangle right here is going to be consumer surplus. That's consumer surplus for the firms in the market, and producer surplus is 0. There's no profits. Now, one firm innovates. It's going to be able to capture the market. It's going to be a monopolist, but it can't act as a true monopolist because C1, this marginal cost, let's see where that crosses marginal revenue, crosses right here. This firm would want to produce Q1. It would want to set this price. The problem is, even though they've innovated, those other firms didn't go away. If you try to set a price right here, this price as a function of this cost, you're going to be undercut by everybody else. So that can't happen. Instead, what this firm's going to do is they're going to take their cost-saving reduction and they're going to allow it to be profitable by setting a price essentially equal to where they were before. So their profits are going to be this rectangle right here. They're not going to set Q1. They're going to set the original quantity or thereabouts, and they're going to get essentially this rectangle as profits. What about the firm with the massive innovation? Well, now marginal revenue crosses marginal cost here. This is the monopoly's new quantity. Here's the monopoly's price. Indeed, this monopoly price as a function of this lower cost is going to actually be able to undercut everybody else in the market who's able to set P0. So this firm now is able to undercut, capture the market, set the single price monopoly price or single price monopolist's price. So this is going to be their profits under the dashed line, to the left of the dashed line, and then above cost. It's this rectangle. Consumer surplus is going to be this triangle right here. Consumers have benefited handsomely. This difference right here, or this triangle right here, is larger than all the economic surplus existing in the market where these were the two costs, right? So there's tremendous gains due to innovation, right? There's gains to improving the well-being of consumers and firms. Now there's this massive triangle right here. What's this? You need to recognize this as deadweight loss. This is the inefficiency introduced as a result of monopolist, right? The competitive market, if the market was truly competitive, would produce way out here. But here's the important lesson. This was the initial state of the world. Everybody was producing with these costs. One firm innovated, drove its cost down to C2. These gains benefited society in the form of this increased consumer surplus, and it benefited them in the form of these increased profits. This is a much larger market, many more gains, economic surplus to be distributed, right? Now, people might be nervous about the fact that this is deadweight loss. And you're like, wait a second, all monopolies are going to introduce inefficiency. And that's right. However, that's taking the wrong perspective. If we want to say that this is a bad situation, that we've got a monopoly producing at this quantity, at this price, and a competitive market would produce way out here, the important thing to remember is the competitive market did not get us here. It was the incentive for innovation that caused this entrepreneur, this monopoly, to innovate and to try to make more profits and then produce this quantity right here. We don't get this quantity. We do not get Q2 from the competitive market. We get Q2 and we get this massive gains to consumers from this incentive to innovate. That's an important economic lesson. And so to say that this deadweight loss, this inefficiency due to the monopoly is bad, I mean, yes, there's inefficiency for this monopoly relative to this competitive market outcome, but the competitive market didn't drive the cost down to C2. It was the monopolist who did. And so the counterfactual, the comparison isn't, oh, let's compare this monopoly price and quantity to the competitive market price and quantity here and see that, oh, we've got all this deadweight loss, which is massive. No, that's not the right comparison. The right comparison is saying, let's look at this monopoly price and quantity. Let's look where we started from. These are massive gains, right? I think that's the important lesson. All right, so I've got a worked example for us to go through. I'm going to show you this first slide, and then I'm going to go through it both in the slides and then with a picture. So the inverse market demand for MP3 players is given by this inverse demand curve. 240, this is going to be the vertical intercept minus 2Q. Market served by two firms, firm A and firm B, initially both produce at equal marginal cost 80. So part A, find the price that each firm should set if they compete as Bertrand firms. Part B, suppose firm A invests heavily in R&D, reduces its unit production cost to C40. Find the new monopoly price and quantity. Suppose firm A invests even more heavily, reduces its cost down to 0. What's the optimal price for the firm? And then my question, what's the lowest possible quantity that allows the firm to innovate and operate as a true monopolist? When is the monopoly able to extract typical monopoly profits? When do we get a large innovation? So you might want to pause, stop for a second. I'll go to a picture where I drew this out. This is an example that's a sort of a teaching example. It's going to kind of show an important thing to reinforce our intuition. I have other examples on my YouTube if you type into the search and look for innovation, I think, and they're typically like Rippin' Good cookies versus Girl Scout cookies examples. All right. So here's that situation. Here's our market price. Here's our inverse demand. Here's the vertical intercept. Here, this gives us a window into our horizontal intercept, which is 120. Marginal revenue has the same vertical intercept as inverse demand, twice the slope. So I'll take 240, double it, make it 4. Take 240, write it here. Take 2Q, double it, make it 4Q. Why that's the case, I've got a video. So if you Google if you go to my search and type in if you Google on my YouTube marginal revenue, you'll see me work through why that's the case. Otherwise, we can just accept that as true because it is. All right. So here's what the picture looks like. Here's the demand curve. Here's the marginal revenue curve. Initially, when all firms have marginal cost equal 80, that's going to be the price. This is going to be our Bertrand equilibrium. Is going to be the firms are going to set a price of 80, price equal to marginal cost. They're going to set this quantity. So when marginal costs are equal to 80, we get the Bertrand equilibrium. Okay, so the firm has then innovated when costs fall down to 40. When marginal costs fall down to 40, now the monopoly price is 140, right? So let me see if I can move this up so we can see where that came from. So let's see. Where did I write this? Okay, so here is our innovation. So our costs had fallen from 80 down to 40. Set marginal revenue equal to marginal cost. Here was my marginal revenue. Here's my cost, which is 40. So move this to the other side. That becomes 200. Move this to that side. That's 4. Divide 200 by 4 is 50. The associated price corresponding to a quantity of 50. We need to go to the demand curve for that. So go to the demand curve. If I squish this down, 2 times 50 is 100. 240 minus 100 is 140. That's where this price came. That's where this price came from. So when marginal costs are 40, marginal cost crosses marginal revenue right here at a quantity of 50. The monopoly price is 140. I'll make this a little. I don't know if that's good or bad. Here I'm kind of regretting doing that, but that's what that looks like. All right. So we've answered. Let me go back just to make sure we've done this. We've answered part A. So what's the price if they compete as Bertrand? Well, it's just the marginal cost. Suppose firm A invests heavily in R&D, reduces its unit production, find the new monopoly price and quantity. So that's a quantity of 50. That's a monopoly price of 140. What price is the firm actually going to set? Well, if I try to set my price of 140, everybody else is already setting a price of 80. So they're going to undercut me. So I can't do that. Instead, I'm going to have to set a price of 80 minus epsilon, right? So I set price equal to 80 minus epsilon. I just barely capture the market. And then my profits are this rectangle below 80 and then out to 50. So it's going to be 40 times, no, this was, that wasn't 50s. 50 is if the monopoly quantity, I'm going to set this true quantity. So I forget what that quantity was. I think it was like 80. So 40 times 80, 320. So, all right, good. So that's what ends up happening if we have the small innovation. Notice what happened here. My cost fell, but my monopoly price was higher than everybody else's price. So that's not good. Can't be a single price monopolist at that price. Now there's a bigger innovation. And before we do that, I'm going to just say, suppose we hypothetically innovated to drive our cost down to zero. You might say that's ridiculous. Well, no, it's not. I mean, there's a lot of industries, especially like internet industries, where marginal cost of zero is pretty straightforward, especially with like internet. Like there's a massive, like, I mean, just so like I'm investing this massive fixed cost making this video, but showing it to one more student via Canvas or YouTube is costless to me. Like marginal cost is zero. So marginal cost of zero is actually pretty commonplace. So in this situation, if my marginal cost is zero, then the monopoly outcome would be, let's set marginal revenue equal to zero, and then solve, we find the quantity would be 60. The price corresponding to a price of the price corresponding to a quantity of 60, it's 120. We actually didn't need to do that calculation, right? If marginal cost is zero, we're trying to find the midpoint of the demand curve. That's the revenue maximizing problem, right? This is marginal revenue. This is my first order condition for maximizing total revenue. The midpoint of the demand curve is going to be corresponding to, well, in this case, my monopoly outcome, but is going to be the revenue maximizing point. It's also going to correspond to where demand is unit elastic. So that's this right here, 120. Uh-oh, there's a problem. When my marginal cost is zero, my monopoly price is 120, but everybody else had a price of 80. So even if my marginal cost is zero, I cannot undercut my rivals as a true monopolist. Am I more profitable? Yeah. Am I able to capture the market? Yes, but not as a single price monopolist. I cannot get a large innovation in this market. So my comment, even as a monopolist with zero cost, it's impossible to capture this market. Why? Everybody else's costs were too low. So my follow-up question was, what's the lowest possible initial starting point cost that allows the firm to innovate and operate as a true monopolist in this market? Oh, we need everybody else's cost to be a little bit above 120. If everybody else's cost was like 120 plus epsilon, I could set a monopoly price of 120 and I'd capture the market as a true single price monopolist. So that's the answer. All right, now let me go through this in the slides. Oh, wait a second. Puppy study break. How about that puppy? I like my puppy. I hope you like my puppy because I like my puppy study breaks. All right, so here was the solution. I'm just talking about this right here. I actually just kind of walk through this. I don't know. Here I'm just going to talk. I don't want to read the slides. I hate doing that. Sometimes I'll want to go back over these, but I actually like the way, I mean, if I was teaching this in class, I would have done what we just did, like on the dot cam or something. And so typically I wouldn't walk through it, but just to verify, like here, this is in the video, it is in the slides. I'm kind of doing this nicely in case, I don't know, maybe let you take a screenshot or whatever in case maybe unbeknownst to me, maybe the handwritten version shows up too small in the video. This is part B. This is finding the monopoly quantity, finding the monopoly price. This right here is setting my price because everybody else's cost was 80. I have to set some price just a little bit below that to capture the market, but I'm not a true monopolist in doing so. Here is finding what happens if my marginal cost hypothetically was free. I'd set a monopoly price of 120, but I'd get undercut by everybody else. So in this particular market, no firm can extract typical monopoly profits, meaning setting price where marginal cost equals marginal revenue. What's the lowest possible cost? We found that actually. So I actually strongly dislike now how I wrote this up in the slides. I'll talk about it in a second. How did I find the last cost level that the monopoly price would go under it? We saw that. I just said, oh, my monopoly price is 120. We need everybody else to be 120 plus epsilon so I can undercut it. There's another way to do this. I'm exploiting something. I'm saying monopoly doesn't operate over the region of quantities and prices corresponding to inelastic demand. It only produces at the midpoint and further. So we know if the monopoly is actually operating, the lowest price can possibly be 120. So here I'm just using our elasticity formula to calculate where the midpoint is. That's silly. This is right here. This is just kind of like getting us practice with the formula. You wouldn't actually do, this isn't how you solve the problem. You just look at the demand curve and find the midpoint is what you do. But here I'm getting us some practice using the economic tools. The midpoint is where demand is unit elastic. So here's 1 for my elasticity. And then here's my dq dp. Here's my p. Here's my q, right? The formula for elasticity is dq dp times p over q. dq/dp is the slope of the demand curve. P is the specific price. Q is the specific quantity. So this is at the price of 120. This is at the quantity of 60, right? And so that's what this is doing. This is just calculating and backing out the price that we'd need. Here I didn't know what the price was, so I was solving for the price. That's a very roundabout way to do this. I don't know. If you really are into Econ 401, if you're really into intermediate micro, or for that class, this is a really good exercise because it reinforces that logic for you. For the purposes of this example, the better logic is what I just gave right here, actually. So, all right. Next thing, so I want to talk about a little bit of game theory. I talk about a technology adoption game. We always think that technology, like maybe we want to adopt the new technology. Well, it's not always the case that the new technology is what we got to do. There's some new technologies that are silly. I remember in my school, when I was in about 5th or 6th grade, we got these large, they're CDs. They're ginormous CDs that looked like records, like for a record player, but they're CDs. They're massive CDs, like several times bigger, probably 4 times the size of a DVD. And that's what everybody was going to go to. We're going to go to these laser discs. And I saw it, and I was looking at it, I was like, even as a 5th grader, I knew there's no way this is not going to take off. There's no way we're going to have them. We had them for about 2 years. School invested a ton in that technology. And then, like, you may have never even heard of this, probably, if you're watching this video. So consumers and producers face a constant technology changes, often find themselves in an adoption game. Let's consider a new and old technology. Assume users face network externalities for both. Network externalities just mean the value of having the particular technology is increasing in the number of other people who have it, right? Like the value of having an iPhone is greater if a lot of other people have iPhones, because you can communicate using the apps that are unique to that ecosystem. In either case, it's better coordinate on a single technology, either new or old, because of the additional benefit from being in the network. So there's a coordination problem. So using the same technology as the other user yields a higher payoff than using any technology alone. And so what I've said is, here's my game. We've got 2 players. One player is choosing new technology or old technology. The other one is choosing new technology or old technology. If the first payoff goes to the row player, the second payoff goes to the column player. If the row player chooses new and column player chooses new, then their payoffs are both alpha. If the row player chooses new, but chooses old, but if the column player chooses new, the row player chooses new, they get alpha. If the column player chooses new, but the row player chooses old, they get delta. And we're saying alpha is bigger than delta, meaning it's better to coordinate than not, right? I don't want to use the old technology if they're using the new technology, nor do they want to use the old technology if I'm using the new technology. And we'll assume that actually the old technology, it's better to coordinate on the old technology than to use the new technology. So we've got 2 equilibria here. It's going to be new with payoffs alpha, and it's going to be old with payoffs beta. That's how this game's going to work. Multiple peer equilibria, new, and old. Notice the Nash equilibria is defined over strategies, not over payoffs. I've got some videos on solving games, and so you might want to check on those if you didn't exactly follow kind of what I did right here. But the game itself isn't so as important at this point as is the concept. So far we assume nothing about which of the 2 equilibrium consumers prefer. I didn't say if it was better to have the old technology or the new technology, just that it was better not to be the only one with the new technology. So that's this coordination assumption right here. What if one technology is superior? We'd say an outcome is Pareto efficient if it's impossible to make someone better off without hurting another player. So the Pareto efficient allocation is one where you can't reallocate, you can't change things without hurting someone. If old is the Nash equilibrium they coordinate on, but new is better, we call that excess inertia. Inertia is resistance to a change in your state of motion, right? I was epsilon away from being a physics professor. So excess inertia means you're staying on the old technology and you haven't gone to the new technology, but you'd be better off with the new technology. If new is the Nash equilibrium outcome that players coordinate on, but old Pareto dominates it, we call this excess momentum, right? Momentum is an impulse. It's mass times velocity. No one cares. So if you too readily adopt the new technology, too eager to change, like my school district, that's bad. That's excess momentum. You should have stayed on the old technology. So excess inertia basically is where the new technology is better, but we failed to coordinate on it. Excess momentum is where the old technology was better, but we switched to the new technology and we're stuck with it, right? Excess inertia occurs when the new technology yields a higher profit to both users. In equilibrium, all users remain on the old technology. Excess momentum when the new technology replaces the old technology, but the old technology yields a higher profit to both users than the new one. All right, so we want to kind of think about these in the context of the fact that you're ultimately playing a coordination game between other consumers and then consumers with the firm in terms of, well, what products are developed and what products are adopted. Anyway, so more on this with product design and innovation kind of stuff in the future. Hope you enjoyed the video. See you next time.